Hi, if you want to get a good basic understanding of API testing, this lesson will enlighten you. I'm Jazz, and I will be your guide today. API stands for Application Programming Interface, which is a set of rules that allows software programs to exchange data. APIs are a way for one program to interact with another and are often used to simplify app development. Let's look at what this means by using a simple non-IT related example to illustrate this. Here's an everyday situation you will recognize. Some customers in a restaurant waiting to be served and a chef in the kitchen waiting for an order. Something is missing here, and nothing will happen unless there is some form of communication between the customers and the chef. That's where the API comes into play, but in this case, the API is actually a waitress. The waitress takes the order, then reads it back to the customers to confirm their choices. The order is then taken to the chef so the correct meal can be prepared. Once this is completed, the waitress delivers the food to the table, resulting in happy customers. Here's what happened in a simplified form. The waitress took the order from the customers, then took it to the chef. He in turn prepared the order. When the meal is ready, the waitress takes the food from the kitchen and delivers it to the customers. The point being made here is that the waitress is the interface, and without her, there would be hungry customers and no work for the chef. The same principle applies to APIs, so let's look at an example. Instead of restaurant customers, there is a front-end order management application being operated by a salesperson. What was the waitress is now an API, and the chef has now transformed into a database that holds details about customers and their products. Name search details are input into the front-end application to see if the customer already exists on the system. The search details are passed from the API to the database. The database will process the request, and once the search is complete and all the information is ready, the database will send the details back to the API, and these are delivered to the front-end application. You now know what an API is in its most basic form, but before we go into more detail, let's discuss why API testing is important. First of all, it allows direct interaction with APIs instead of the front-end application screens, also known as Graphical User Interface, or GUI. This approach helps identify issues early when front-end applications are not fully developed, and it also makes it easier to get full coverage of responses. Full coverage is not always easy to test on a GUI. When data requests are injected directly into the API, it will also enable you to start performance testing. In summary, using an API directly offers a comprehensive and efficient testing method. APIs handle critical operations like user authentication and data retrieval. Testing ensures they function correctly, covering data formatting, error handling, performance, and security, which are essential for application stability. First, we'll discuss data formatting. A key component of API testing is validating data formats like JSON and XML. Testing the structure and format can prevent errors such as incorrect data types or missing fields. A typical API response might look like this example. APIs return responses in standardized data formats with JSON, JavaScript object notation, and XML, extensible markup language, being the most common. Ensuring that these responses adhere to the correct structure and format is crucial for downstream applications that consume the API. The example on show here is JSON. Here's a JSON request that returned the data in the expected format. Because it's successful, it will show a status of 200. Your initial analysis of the design documents would tell you what data type to expect. However, the next example has an incorrect data type. Can you spot it? Pause this video if you need time to look at the JSON code. There is a data type error on age. This field should be an integer, not a string. You will receive an incorrect data type message like this. An error code in the 400 range is usually returned for these types of errors, and the API should provide enough information to allow you to understand the issue. The next example shows an error that is a bit more obvious. Can you see the issue? There is a missing password field. In this example, the API will most likely create a message like this. An error code in the 400 range is also returned for missing data. This is slightly different in its description from the previous error, but it's the same code as used for incorrect formats. Let's have a quick look at the number ranges used in API responses to understand what they mean. An error code in the 100 range is informational, but won't stop the processing. Anything in the 200 range indicates success. It's good to get these in testing. The 300 range means that further action is required. For example, the request has more than one possible response. The client can choose one of the available options, and the server provides links to these options in the response. The 400 range is where there's an issue with the client request. We have already seen both our messages have a code of 400, which is a bad request, like missing fields or incorrect data types. The 500 range indicates that the server encountered an error while processing the request. The issue is usually on the server side and can typically mean there could be server misconfigurations, database connection failures, unhandled exceptions in server-side code, or a resource overload or server crash. These number ranges help both testers and developers identify the status of the request and what kind of action is needed next, if any. Checking API response times and error handling is also crucial. Testers should simulate scenarios to ensure APIs provide meaningful error messages and proper HTTP status codes, maintaining stability and predictability. When checking API response times, this is normally done under load using specialist tools, which may involve creating hundreds or thousands of messages per second. A good load test will ensure the expected number of transactions can be handled without a bottleneck or errors. These tests can vary in length, and some can go on for hours to simulate a prolonged period of peak activity. Here's a list of commonly used tools. It's a starter list, and there are more on the open market. These tools vary based on factors like ease of use, supported protocols such as REST, SOAP, or GraphQL. We'll briefly discuss these protocols later in this video. Selecting the right tool also depends on its scripting capabilities and integration with CI/CD environments. In case you're wondering, a CI/CD environment in IT refers to the setup used for continuous integration, CI, and continuous delivery/continuous deployment, CD, which are modern software development practices. These practices aim to improve the speed, quality, and efficiency of delivering software. The choice of tool depends on the specific needs of your API testing, such as whether you prioritize manual testing, automation, or performance testing. Don't worry yet about which tool to use, that will come with experience. It's enough for now to know that these tools exist. We'll finally look at security testing. This involved using OAuth and JWT. OAuth is crucial for API security testing as it provides a secure authorization framework, allowing third-party applications limited access to user data without sharing credentials. JWT, JSON Web Token, secures API communications by transmitting authentication data via digitally signed, tamper-proof tokens. This protects the integrity and confidentiality of the user's information during transactions or interactions with APIs. We have now covered the different types of testing, but I want to briefly mention that there are multiple flavors of API in use, but the testing principles are the same. You are looking for error-free and performant responses to any request. There are many protocols in use, and here are a few common ones. REST, meaning Representational State Transfer. SOAP, meaning Simple Object Access Protocol, and it uses XML. And GraphQL, a query language that allows clients to specify the data they need. The most widely used API protocol is REST, also known as RESTful, and it works over HTTP. It uses standard HTTP methods GET, POST, PUT, and DELETE, and typically communicates using JSON or XML. Just for clarity, GET, POST, PUT, and DELETE are the same as READ. Create, update, and delete. When you rearrange these, it comes up with the familiar acronym of CRUD. If you are unfamiliar with this, it's worth remembering, as it's widely used. If you want to know more about APIs, leave a comment and we'll answer your query or create another video with your suggestions. Thank you for joining this session on API testing. Now you know the basics, it's time for you to get stuck in. Talk to your test manager and ask if you can enhance your skills by helping with this type of testing. Mastering these skills is becoming essential for test analysts in today's API-driven environment. For more testing insights, use the link below this video. There's lots of useful lessons there, and don't forget to like and subscribe. It helps us to create more free content.